I'm going to be doing, I hope you've been having a good convention so far. Last day, depending on your time zone, I guess. Appreciate you coming out to this panel here. So this panel is from first steps all the way up to essentially managing full-on projects. So there's going to be a lot I'm covering in here, maybe a little fast. But this panel is set up to be a reference, so it will be available later. So if you ever miss something and need to flick through it, you'll be able to do that. So first question you may be asking, who am I? I have been in VR chat for roughly 3 years now, doing everything from making avatars to making different assets, releasing things on Gumroad, building various tech demo worlds, maintaining various different VCC projects, even things into looking into like how the SDK works and whatnot. Pretty much a little bit of everything. And this has been an amazing thing for me to really stretch my legs in. But you may be still asking, like, why am I doing a panel on Udon? Well, for a few reasons. First of all, I've really gotten into maintaining like probably one of the largest projects I've ever worked on. OpenFlight, I'm sure a lot of you know what it is, and if you don't know what it is, it's essentially an in-world system that allows you to fly like a bird using your hands. With a bunch of additional features and the ability to change settings and automatic detection and a lot of other things that I wish I could get more into here. I have a pretty extensive GitHub account. I do commits almost like every day. And we've the amount of users that the system that I maintain with one of the co-creators is extensive. It's at least 48 worlds. Estimation like 600-ish users an hour, and that's very rough. So that's why I'm coming here and doing this panel. Is I thought there was a lot of stuff in the space that I have not seen out there that I feel like is missing, and a lot of stuff that I've had to figure out. So this is kind of supposed to be a reference panel to fix a lot of that issue. So the first thing we're going to talk about is coding environment. Maybe slightly a little controversial here, but I use VS Code for doing pretty much anything that I program. I know a lot of people like to use Vim or Rider. Some people are insane and will use Notepad. But the main thing here, this is the most important thing. If you take anything out of this panel, setting up a proper coding environment is extremely important, because if you don't, you're essentially just writing text with having almost no clue what you're doing. And even if you do know what you're doing, you're going to make a crap ton of errors. I guarantee it. So having a proper coding environment fixes a lot of that for you automatically. Now, the main reason I use VS Code is because of extensions. Extensions are amazing. Having a base code editor that you can just almost add anything you want to is extremely powerful, and the main reason I've used VS Code continuously. I have a few different sets of extensions here. So these ones I highly recommend having installed in VS Code if you're going to use VS Code at least. Some alternatives exist for other coding editors. So first you have C# or C# dev kit. That's going to be your actual language support. So VS Code knows what you're looking at when you open a C# file. Another really useful one is C# prettier docs. This one, and we'll get into this later, but this one essentially formats XML documentation comments in your editor. So one, you actually want to look at them because they're not colored the same as normal comments. And I don't know about you, but I gloss over a lot of normal comments unless I'm trying to figure out how something works. And it also, it just provides a level of separation that makes them stand out, so you actually want to read them, and if it's your own code, maintain them. Another one is C# here. It provides some formatting tools in VS Code for C# specifically. Another one I'd recommend here is GitHub Copilot. This one has probably been the biggest changer for me as far as doing any programming, even just outside of Udon development. having essentially almost a second person there just go like, hey, yeah, I know about this random thing, maybe you should use it in here, or being able to write boilerplate for you, and then you just have to go tweak slightly how it's organized, has saved me so much time. I wish I had statistics on it, but I have to at least guess it saved me days of work at this point. And it's even essentially taught me things that I didn't know was part of the language that I was using, because it will just suggest things. I'm like, you can do that, and then I start using it everywhere. Another one is Roslinator. It's a set of essentially language server extensions that do a bunch of additional checks on your code for C#. And the last one is Unity. The Unity extension in VS Code. It's named a little confusing, but that allows you to attach a debugger to VS Code, and also fixes some of the language server issues, because a normal C# language server gets confused when you have something like void start or void update, because it's going to complain that they don't exist and a bunch of other things. Installing the Unity extension fixes that for a lot of the built-in ones that just get like invisibly called almost. So then I have a set of miscellaneous extensions here. None of these are really, I wouldn't consider them required, but I think they're fairly useful as well. To do highlighting, fairly useful if you have a lot of code that you maintain for a while. You can just make a comment with capital to do, and it'll highlight it yellow, so you know that it's there and you try not to forget about it. I have a few for regions, region highlighter, region viewer, and region with colors. Region viewer gives you essentially a hierarchy view of all of your regions. And region with colors essentially colors the blocks around regions. If you're not aware what a region is, it's essentially an advanced form of comment. It doesn't actually really mean anything. The reason I use them is some things that you program just are going to be longer than your code editor window in like a method, and there's not really a way to split them up. Using regions allows you to split that code up and be able to fold them away without having to make them dedicated like methods. And the region highlight kind of helps with that, because it gives you a more direct visualization of, you know, what is this block of code is this region, this block of code is another region. It's just kind of an organizational thing. One of the other ones on here is Discord presence. Entirely unnecessary, but I think it's cool to have on your Discord profile that you're in VS Code and you've been in there for like 3 or 4 hours working on a C# file. There's a bunch of configuration options that you can hide what you're working on and whatnot in case you're working on sensitive things, but I think it's fun to have. Lastly here, I have some for shader editing. This won't really be part of this panel, but I thought I'd mention it in here anyway, since I'm going over coding environment. If you install most of these, it will allow you to actually edit shader files with, you'll get a form of language server support as well. It's not great, but it's way better than having nothing. And your language highlighting will also work properly at that point. So yeah. So the next thing I'm going to go over here, this first video here is about language servers. It shows off a few different things. Firstly, the ability to have an automatic drop, like autofill thing show up that essentially searches through your project and shows you everything that you could fill in there. The next thing is selecting a code block. You can refactor it out into a method. It'll automatically determine everything that's required there, including parameters. You can also right-click on things and rename them, and it'll automatically make sure everywhere that it's used actually gets renamed, including like you can rename them from where they're not declared, which is really useful if you realize that you named something wrong. Another one is documentation comments, which again sparse throughout this panel, but you can see here if I hover over that method now, it has that comment set up that I just gave it. I use this everywhere in the code. I cannot recommend enough doing it. Another thing I just did here is I selected one of the VRC SDK methods there, and I did go to definition. What that just did is essentially opened up it decompiled the SDK part there and showed me everything that class has, and this even works for your own code. If you do that on like when you're using a method, it'll move your cursor down to where that method is actually defined. Same thing for variables. It's very useful if you're you have no idea where you wrote this, or it's someone else's language and you want to, or someone else's code base and you want to see how it works. Extremely useful. The next one here is going to be alt selection of code. This is also very, very useful. You could select multiple lines all at once and do things to all of those lines at the same time. This is especially pertinent if it's something that like you can't have an array for, just due to the way it works. So you have a lot of method calls and you need to change all of them at the same time. I've used this extensively. Even if it's just 2 lines, it's way faster than going to the first one, typing it out, and then doing the next one, or even just copying it around. The other thing that you can do is select a set of code, and holding Alt, you can shift that selection of code around, up and down. This works on pretty much anything that you have selected, including methods. So if you want to reorder your methods, you can just select the entire thing and just shift it up. And it's super useful for reorganizing stuff, because you're not constantly, copying and pasting stuff around, or forgetting to paste stuff back in, or getting malformed. Extremely useful. The last one here is going to be block comments. There's 2 different ways to do this. You can select the area that you want. You can either do a mode in here that for every single line it'll do comments, or you can do a multi-line comment mode. The multi-line's a little jank because the multi-line one depends on where your cursor starts and ends. The single line one doesn't do that. So the multi-line one is a little less usable, but it's also cleaner because it's a multi-line one. You don't have a bunch of slashes everywhere, so it's kind of a preference thing. But still useful if you need to like comment out a section because you're testing something else, or rewriting it. So next up here is going to be some capability misconceptions. I see a lot of people confused that you can even do certain things in Udon, even like community heads that maintain various different worlds, like all the YouTube worlds and like Udon Tycoon and stuff like that. There's a lot of stuff that people just don't seem to know that you could compile, either because they haven't tried them or just it doesn't seem like it would work. This is not an exhaustive list by any means, but it really just to show you, like, just experiment with stuff. Try out something that you do in a normal C# project and see if it compiles it or not. You'd be surprised the amount of stuff that you can get away with. So the first thing, access modifiers. Please at least learn like 3 of these. I'm sure a lot of people already know the difference between public and private. Public, pretty much everyone can see it. Private, only the class that you have defined can see or use that. But there's a few other here that are useful. The main one that I use as well is internal. This is important when you get stuff in namespaces. Essentially, and we'll get into this later, but essentially everything in that namespace can use whatever is declared as internal, but the second it's outside of that, they can't see or use it. So like if you have like package A, you can define stuff as internal in there. Everything in package A can see or use that, but then in the actual like assets folder or whatnot, where end users are using it, they can't see or use any of that stuff, which is very useful if you need stuff that's more wide-reaching but still isn't really an API thing. It's just internal logic that you need everywhere. So that's really useful for that. Methods can be very complex in U#. This is just a few examples of ones that these are all in real projects. You have simple stuff like just a normal event, but you can work up to having returns going on. You have multiple different parameters you can passing in arrays, a few different keywords going on. There's a lot you can do, and I don't see people having more complex stuff a lot of times, or doing like other weird workarounds when you could just make it a single method. You can even have what are static methods, and you can have generics. So what a static method is essentially whatever that method is, it's completely untied from the instance of that class itself. So I can have 2 different scripts, both be able to call the exact same method. So essentially, a great example is a utilities class, right? So if you're like packing bits and whatnot, you don't really want that to be part of any specific script because it's just a utility that you've written. That's what you'd use a static method for. And it essentially ends up with the same code ending up in the two locations. Generics are really cool. They essentially allow you to define a method that works for multiple different types. So like, let's say I want to get a script that's type A or type B. The initial way you do that would probably be having two methods to do that. Using generics, you only need a single method, and then you just tell it when you call the method what script you want to get. And you can even have this applied to the return of the method as well. So if you like do something to it, or you want to return some other type, you can have that as part of the declaration as well. It's an extremely useful thing to know as well. Not that it comes up that often, but when you need it, it's really useful. So another keyword is the params modifier. This essentially allows you to avoid having to have a new array declaration in your code. It's technically doing the same thing behind the scenes, but it just is a lot cleaner. So if you have a method defined like this, there's three different ways you could call it. Normally you just make a new Boolean array and then either have that as a separate variable or just make it inside of when you're calling the method. Using the params one, it automatically does that, and you just can divide each parameter with a comma, like it's another, input to the method. It just cleans things up generally. Another one useful here is the out modifier. This is extremely useful if you have any form of data validation that you need to be doing with a method. So like, let's say you're building a database system and you want to make sure when you did something, it either worked or failed before you use the result of it. Normally you'd have to have two methods or some really weird logic to go on and do that. With the out, what you can do is you can define the return of that method to be the success or failure of if that operation worked. And then you can return the result out through the parameters. So you can see I have an if statement in there. If the method returns true, I then use the result variable that it made from setting it. So doing that is extremely useful, especially for database stuff, if you ever implement anything like that. Or if you just need something that has multiple outputs all at once. Another useful thing here is ref. So normally when you pass things into a method, in C# at least, the parameters in the method declaration are essentially copies of what you passed into it. So if you were to change any of those when you're in the method, those don't make it anywhere outside of that method. So like, for example, if I was to change the length of an array, that array change doesn't make it to where I actually called the method. Using the ref modifier, you can change that. It actually does make it that way. So for example, here I have a new Boolean array that's 20 elements long. I call this function, and inside of it, it sets it to 3 elements long. Outside of that function now, that array actually will be 3 elements instead of still being 20. So fairly useful if you have stuff that you want to mutate data, but you don't want to have to like keep reassigning it back, because that looks messier doing that. Instead of just having a reference to it, and it just does it. You can even do recursion. This doesn't come up that often, but if you're working with tree structures, it can be very useful. And it doesn't work. The reason it doesn't work is because you need an attribute to specifically tell U# to compile things differently. Because recursion, it's a little complicated, but dealing with recursion as far as a stack goes is a lot more complicated than just you can only call the method once, because it's continually calling itself and it has to deal with a bunch of frames and whatnot. So you have to specifically tell it that you're allowed to do that. Otherwise, it will just not execute it for safety reasons. But yeah, that's also a method that you can do. If anyone knows what coroutines are, you can also kind of do those. They're not true full coroutines, but they are possible to be done. This code here is essentially it essentially recreates update, except you can manually define what the update rate is. So in this case, it's every second that method will call itself. So instead of having to have some form of check continually going on every single frame, you can just let Unity deal with it. and it'll just call that method back every single second instead, which could be significantly better for performance. Inheritance, a little bit of a controversial thing, but I do like inheritance as long as it's not taken too far. Inheritance is essentially the ability to copy things from one class into your class and just have it be available. So in this case, I have one class that defines a Boolean and a method, and in the class that I'm the class that I have defined that's inheriting from that automatically has both of those things in it. This is mainly useful in U# for defining base classes that give you a lot of additional functionality without having to copy code around, which I'll get into here in a second. Yes, this is something you could do. As long as the lowest level thing you're inheriting from inherits from a Udon sharp behavior. That is the only requirement for doing this. But otherwise, you can have as many levels of inheritance as you want. String.format and multi-line strings. Multi-line strings, I actually, Copilot showed me, like, I don't know, it was like 2 or 3 weeks ago, how to do those. It just suggested it, and I was like, yeah, sure. I didn't know how to do that. String.format is really cool. Normally, the way you would have been taught how to combine strings that have data in them would probably be concatenation, where you just have the string and then you do a plus with whatever variable and then you add on more strings. That's horrible. Just visually in your code, it looks really bad. And then it's also just hard to read, right? And you also have the issue of if you want to reuse a number multiple times, you have to make sure that every time you do that, it's the same way that you're getting that number. String.format fixes pretty much all of those issues. You give it an initial template, and you can define with curly brackets and a number what index of parameters to use. So in this case, I have 0 and 1 in this string. So the 0 in this case will pull from the false, and then the 1 will pull from that number there, and it automatically does the concatenation for you. The other advantage with this as well is that you can have multiple instances of the template name used. So if you want to put something that's in that template multiple times, you could just have multiple of the 0 definitions. There's some other advanced stuff you can do that I don't really use in the template, but there's even more options as far as that goes. I use string.format everywhere now when I'm logging things, because it's a significantly better way of doing things compared to here's a massively long string with everything concatenated onto it. Another thing you can make is a subscribable event or callback system. I really recommend, even if you don't use my code example for this, having some form of this, because this can save a lot on frame times. Namely for things like UI, because if you have different UI elements that need to update, a lot of the times you don't actually need them to run on update every single frame, because they only get updated when other things happen. So what this allows you to do is trigger a callback via the inherited class that I have here, and it's pretty much invisible to anyone that's actually either defining the callback or subscribing to it. So this was the main advantage of the inheritance that I showed earlier. If you want to get access to the base class here, I have a QR code there. There's more QR codes throughout this presentation. You don't need to scan them now. You can just take a picture with your VRC camera. There will also be a QR code at the end of the presentation with the entire slides in it, in case you missed them. But I highly recommend setting something up like this at least. Another thing you can do is having custom loggers. Setting one of these up is also really amazing for debugging. So the way that this is set up is essentially a copy of debug.log. You just have to pass it a reference to the script that's calling it. It does a bunch of additional formatting behind the scenes and then pushes it to an actual game object in the scene. So that allows you to actually do runtime debugging in the world through just a single text mesh pro object. And the base classes for that are also provided in there. I wish I could go more in depth on how these work internally, but I do not have the time, unfortunately, here. But if you'd like to ask me afterwards, that is an option. I can go more in depth in these. Enums. Enums are also a really cool feature. They are essentially a way of hiding what a data type is behind a bunch of named numbers. So let's say you have an integer. You can essentially name the value for 0, the value for 1, value for 2, so on. So for example, if I was making a Minecraft clone, you could have block types as a byte enum, and instead of saying having to memorize like what is 0, what is 1, what are these blocks, you could just name them what the blocks are, and your code becomes a lot more descriptive for the same exact result. You can also use these for flags. So if you have various different flags on something, let's say like the Unity layer system is a great example. That's essentially a flag. You can have multiple of them on. You just have to manually declare them in powers of 2 by using the equals with the number. But that's how you would use them for flags as well, which is a useful thing to have. Field change callbacks and properties, also extremely useful. This essentially allows you to say if the VFX field here, for example, changes, it will go execute the property over on the right. Properties are essentially a way of having something appear like it's a variable, but then you can override the way the setter for that variable works or the getter for it. So you can have it return entirely different information when you ask for it, or when you set into it, it can do something entirely different. It's a really nice way of changing the behavior of how variables work without having to have methods involved, essentially. Doing code profiling, also maybe not straightforward, because if anyone's tried this before, you've probably tried the built-in Unity methods to do this. Well, those aren't exposed for some reason. So what you have to do is use the diagnostics stopwatch class in the system namespace. You essentially just make a new stopwatch and start it, and then once you stop it, you can get out the milliseconds that have elapsed in that stopwatch, and it gives you an extremely accurate time of how long that code block has taken. I've used this extensively, especially for for loops. If you have really heavy for loops and you're wondering like, why is this so slow, you can essentially have multiple levels of stopwatches and then print them all out at the same time and kind of break down where your code is taking longer. Highly recommend doing this, especially if you're getting heavy slowdowns in your Udon code. Editor scripting. I wish I could do a whole panel on editor scripting, probably, if I wanted to. There's a lot of amazing things that you can do here by adding things to the editor or doing things on scene build. But just the examples that I have here, OpenFlight has a system where we embed the version directly into the prefab. That is using an editor script instead of being baked into the text object itself. So when the scene is built, when you go to upload the scene, it will pull out the version from the package definition itself and put it into the string that defines that text object. So I don't have to update anything other than the thing I'd already be updating to update the package. And it just automatically works for everyone else. If you don't have to get too heavy into editor scripting, but if you do any form of large project where it's a package for people, I do recommend doing this at minimum. Because it prevents you from making a mistake and not incrementing that number properly. Because I've seen that a few times already in other projects where they just don't increment the number, and now it's confusing because the version number is wrong. Now, one of the probably bigger topics of this entire thing, networking. The VRChat docs have said that networking is extremely work in progress, and that string has been there for the past probably 4 or 5 years now. And I can completely agree with that opinion. So the first things you're going to want to understand when you're doing any form of networking in Udon is, what are these debug tabs? You're going to be looking at these a lot. The main things that are important in here is the name. That is the name of the game object. You can change that at runtime. That does update. The owner, that is the player ID that owns that object. Owners of objects are the only ones that can actually set variables on that object. If everyone else tries, they don't actually go anywhere. They get overwritten. The other important thing in here is size. That is the byte size of that object. The larger that is, the longer it's going to take when you serialize that object to make it to other users. So generally you want to keep that as small as possible while keeping whatever your implementation is. In bits per second, that's basically how many well, it's actually bytes per second. How many bytes are happening per second? It's very rough. The max that we're limited to is about 8K bytes per second. But it's still not entirely that. It's kind of complicated, but that it's a rough marker for that. The other important tab you're going to want is this one. There's a lot of stuff in here. Most of it you really shouldn't care about. It's more stuff for the devs to understand what's going on. The one you do want to understand here is the suffering line. That is essentially the number of bytes that have yet to be serialized and sent out to other users. So if that value is non-zero, there is a script that is not finished serializing, which means that it's not on other users' machines yet. And that number ticks down about 10-ish every second. It's not linear. It's really weird, but that one is important. If you're wondering why stuff isn't updating as fast on other people's machines, you should check that out. And if you have anything non-zero in there, that means stuff is continually waiting to get out. So another thing here, you really, like always, really should use manual sync. Continuous sync, you are limited to roughly 200 bytes per object maximum. If you go over that, it just won't serialize them a lot of times. If you use a string type, for example, you can have only about 126 characters, which really isn't a lot if you're doing things with strings, other than maybe a name. It's also constantly serializing data, so it's going to eat into that suffering size that you have available. And the problem with that is, the only way to disable things that are continuously synced is by turning the game object off itself. There's no toggle that turns it off and the game object is still able to run. You have to completely turn the object off. Compare that to manual sync. We can sync about 280 kilobits, which is about 0.28 megabytes. It takes a little while, but you can do it. That's still less than a standard 3.5-inch floppy disk, like the lowest size that you could get, which is about 800 kilobytes, 740-ish when formatted. So if you even wanted to just support a floppy disk over the network, you need 3 scripts to do it, which is, yes, still insane, but way better than 200. And the other nice thing with manual sync is it only serializes when you actually tell it to serialize. So it's not constantly eating up the network cost if you just sent like a Boolean and you can just leave it over there with other users. So another thing you might want to do if you transition away from continuous sync is you might still want the way continuous sync works. So what you can end up doing is using the properties that I showed you earlier and essentially set up a system where when you set the variable, it'll automatically do the serialization request for you. So it's functionally continuous sync, except for the fact that you're not paying the entire networking cost otherwise. The other nice thing about the code that I have provided here is this will check if the value that you're trying to set it to is already on the network, and if it is, it doesn't request serialization at all. So you're not unnecessarily requesting serialization for anything that if you're not changing the value at all, which is just kind of a safety check to make sure if you're setting it every frame, it's not continually trying to sync it. Now, this is also probably going to be a little controversial. Networked method calls. You're going to hear a lot of people talking about, oh, all of your methods need to have underscores in them, and they need to be, your access modifiers need to be correct. Frankly, I don't think it matters that much, and I'll get into why here in a second, but all methods with any parameters on them automatically are non-networkable. U# does this for you. When they compile, they all get underscores added in front of them. Any scripts that have sync mode other than none can have non-parameter public events / methods called. Anything else does not actually get called when you call them over the network. It does not have any parameters and you over the network, you just have to add it up. Now, the reason I don't think this matters as much is because the people that are going to be abusing this are going to be client users in the first place. But the thing is, client users have the ability to just delete other players' player controllers and various other really bizarre things that they really shouldn't be allowed to do anyway. But frankly, your Udon scripts are not going to be the attack vector that they go through anytime soon. So it really is not a big deal if you don't follow this. It's a nice standard, but I frankly wouldn't care if you don't do anything with this information. Now another thing, you should never really ever sync booleans directly unless you have a single one in your script. So the example on the left, you would think, oh, this is only going to take up 8 bits because it's only 8 booleans. Well, due to how U# syncs things, Udon in general syncs things, each of these booleans is actually 2 bytes. So this code on the left ends up being 16 bytes over the network. To solve this, what you end up doing is you set a single byte as the thing that you're actually synchronizing, and then you essentially pack all of the booleans that you want into that single byte, and that ends up becoming just 2 bytes over the network. So you save 14 bytes by just packing them into a single one. This is totally something that should be done by the client for you. You shouldn't have to worry about this at all. But for some reason you have to. So I recommend never synchronizing booleans directly unless you only have exactly one in there. And these are just examples of the packing and unpacking functions. You can see I use the parameters, the params keyword in there. Sadly, the params keyword doesn't let you define a compiler level check for how many parameters are allowed. So I just have to check it at runtime. But this does still clean up the code if you have a lot of things that you're passing into it. You don't have to make an arbitrary new array. Another thing, you're going to want to be careful about arrays. This is kind of a hidden cost. Arrays have a 52-byte header that is attached to them, even if you have 0 elements on them. So if your data, if you were to split it out into individual variables, like let's say you're just synchronizing 3 colors, for example, and you're only ever going to have 3 colors, the array size is essentially static. Those should really just be separate variables, because the cost of those 3 colors, byte size wise, is smaller than just having the array there in the first place with no elements in it. And so it's the case with pretty much every data type that you can serialize. The other thing to consider here is each additional element of an array only adds the size of the data type itself. It does not add on the additional header size that is there. And there's some logic as well. Every 4 bytes, they'll increase their size. But the main takeaway from this is if your array size is going to be extremely static or really small, you really just shouldn't use an array. You can get away with using an array by having the things that are synchronized, variables, and then you use an array property essentially to give you back an array with all of those variables added into it. If you really need the functions of an array where you can loop over it and whatnot. Here's a fun little bug that who knows when they'll fix. So if you use a character type, you can, you do A, B, C, D, whatever in that character type. Well, the type supports all of the characters in UTF-16 standard. The problem with that is VRChat only serializes the least significant byte of the character definition, which functionally means that you are limited to having just the extended ASCII table of characters that you can synchronize through that, essentially. And the other fun thing about that is, since it's the least significant byte, it rolls over after 255. The simple fix around this is serialize a short and then have a character property that essentially interacts with that short. And you end up having enough size to put the character into that short. It shouldn't have to work around that. I have a canny open for this, but I have no clue when it'll be fixed. Because as we all know, it's kind of a dice roll when or if things get fixed. This is especially pertinent, by the way, if you're in like the Japanese community or Chinese community or whatnot, because all of those characters are UTF-16 area. They're not in the extended ASCII table at all. So if you use a normal character type, it won't work. So the next thing here, there's some additional hidden data to consider as well. Each script definition has a 12-byte header attached to it automatically, even if you have nothing in it. This doesn't come up too much, but you might be wondering why your numbers are larger than they should be. This would be why, and it's a little invisible because normally you're not going to have a script that has nothing on it because it's not doing anything at that point. And this is also as of 1/21/2024 because they might change this because it's kind of internal data. Now, here's a little mini pop quiz. I want you to think about this. Is there any reason that these two should be a different size? For anyone that can't read it, the left definition has a short A, short C, and a Boolean B. The right one is a short A, short B, and Boolean C. The only difference between these two is the variable names are different. Now, hopefully I've given you enough time to think about this because you're probably wrong. These are not the same size. VRChat attempts to do an optimization where if you have two of the same variable right after each other, they don't need the header for the second variable definition. So every other variable you have of the same type does not incur the header cost. Well, for some bizarre reason though, when it goes to do this optimization, all of the variables are sorted by their name, not their type. So this leads to, depending on the name of the variable, you either have a larger or a smaller byte cost. And it's bizarre that it's worked like this. It's suggested internally that they fix this, but again, dice roll if this gets changed, sadly. And I've attempted numerous different ways to figure out the way that this is sorted, so I could give you guys a better idea of how to fix this yourselves without just having to deal with it. Except it's not straightforward. It's not directly alphabetical because for some reason G and I are switched if you were to sort it alphabetically. And it's not directly numerical either. If I find more stuff on this, I'll try and point it out or give like ways to mitigate it, but so far we have not been able to crack on the way that this is exactly sorted. And of course they won't tell me why, even though there's fundamentally no security reason why it would matter for them to keep that secret. So is what it is. So you may be asking yourself after seeing all of this stuff, how in the world do you calculate how large your data is? You don't need to do this manually. Even just the stuff in here, I've put in the equations needed, but like a lot of this is constants that you'd have to eke out. With that QR code, if you go to there, it'll redirect you to a Google Sheet that I have created that allows you to put in all of the variables that you're using on your script, and it even supports arrays, and it'll tell you what the best and worst case serialization size will be for that script. It even shows you what that'll be in continuous sync, because there's some slight differences in continuous sync that I didn't cover in here, even though I really am not a fan of continuous sync. It is slightly different. It'll show you as well how close you are to reaching the maximum serialization size. So if you're ever wondering on how to like optimize stuff, I highly recommend going over there and checking that out. Another thing people might be wondering, with us getting access to data containers, they are not directly serializable. So if you try and serialize something like a data dictionary or data list, it won't work properly because it's just not something that's set up to serialize correctly. So what you end up having to do, the simplest option at least, is converting the data container to a string and then serializing that string. This isn't the most efficient option. You could build a custom serializer out so it takes up a significantly less amount of space, but that's a lot more complicated and somewhat outside of the scope of what time I have here. But just know that it is possible to serialize them. You just have to put in a little additional logic to do so. So next up here is some performance myths and misconceptions I see around quite a bit. First of all, Udon Sharp isn't a traditional compiler. It really is a compiler almost at all. It's what we call a transpiler. A normal compiler is going to do a lot of optimizations for you. It's going to remove, all of your unnecessary code and just simplify a lot of things for you as it translates it to what needs to run. Transpilers are essentially taking your code and just running what is the equivalent of Google Translate on it, for the lack of a better term. So it'll run, but it's not really going to do almost anything for you to improve the performance by just analyzing what code you have. This is really important at Udon, where some things you can do are really bad for performance. So then you may be asking, what is actually being ran when I'm mentioning the Udon and the Udon VM? What is actually being ran is essentially an extremely limited version of assembly. There's only 9 opcodes available, and there's a stack/heap that can be used for variable storing. That is it. This is all that the Udon VM runs. This is what runs every single Udon script you see in every single world. This is all that is in those definitions. So the other fun thing about this, there's a no-op, and an annotation works like a no-op, which don't get me started on that. But the no-op is functionally useless other than working around a few bugs that the Udon VM has, because Udon runs on the main thread anyway. So if you were to no-op, you're just going to be pausing the main thread to run your code. So there's not really ever a reason to run a no-op. It would make sense if it's on a separate thread at that point, but since it's not, it's functionally useless. Everything else here is either interacting with the heap, jump commands, or extern. Extern is how you do anything in Udon. Here I have an example of just a script of adding to an integer and then printing it. There is 3 externs used here, one for adding to that integer, another one for concatenating the string and the integer, and then another one for calling the debug.log method. So you hear a lot of people say minimize externs. I really am in disagreement with ever saying that, because it means almost nothing when you add one to a variable as an extern. The thing that's really more useful is if something you're doing is a Unity method that's already built in, you really should be using that. There's no reason to go and like rewrite a physics system unless you absolutely need something that isn't built in. And even then, you might be able to get away with some components to help you. Anything you can offload outside of the VM level into the normal Unity editor scene, you really should be doing. Because it just saves a lot of frame times, because externs have an additional security costs that they have to run and check a bunch of stuff before it gives you the result. They add costs, essentially. So you may be asking though, does any of this actually matter? Yes, it surprisingly does. These 3 code blocks, you would think in a traditionally compiled language, these all produce the same exact assembly. Sadly, these do not produce the same exact assembly. The one on the left will do individual checks for every single if statement you have, even though their scopes are exactly the same. The one in the middle, at least, can early exit, because it's an if-else. The one on the right just does it all at once, pretty much. It's still doing it individually, but it can do some slight optimizations due to the way that it's defined. Going from the left one to the middle one, in a for loop that I was doing on about 9k elements, saved me about 10 milliseconds. By just adding the word else. So this does surprisingly matter, and it's kind of annoying that you have to think about this, because this really should be done for you when your script is compiled. But it's just something to keep in mind. If something's running slow, kind of look at it and see if there's a reason that like you can't have the same behavior by doing something else, because it might end up being faster. So the last thing I'm going to touch on here is actually managing and maintaining larger projects. So this is kind of the advanced level of doing stuff here. Namespaces, you've heard me talk about them a few times now. They're one of the more amazing things about the C# language. They are functionally folders for your code. So here I've labeled a set of namespaces that I have defined, and also what folders that they associate with. And this maybe isn't directly straightforward yet, but if I show you, if I show you this, I have 2 classes that both have the same name, that have the same named method inside of them, that do things differently. If you were to not have the namespace definitions in here, these 2 would fail to compile because they're named exactly the same. By having the namespaces in here, what that essentially allows it to do is separate out those 2 classes into 2 entirely separate things, so you could use both of them even though they're named the same thing. This is extremely important in packages because you don't want to have variable names or classes end up having the same name as stuff that end users might have in their projects already, which can happen quite often depending on how you name things, right? So doing this kind of avoids that issue entirely, and you don't have to worry about name collisions. C# XML documentation. I've already touched on this a few times, but please do this. Like, even if it's your own internal logic, you really should be doing this because you're not going to remember how something works in about a month when you have to go maintain it again. And the other nice thing about this is your language server will pick up on the fact that this is here and just show you on hover anywhere where that is used how that works. The format's pretty simple. It's just XML. You use 3 slashes to define them instead of 2. And this can also be embedded into online documentation as well. Which leads me into Doxygen documentation generation. This is essentially a way to get a website view of your entire code base, and it'll show you all of that documentation that you have now written in. So this is a great way to explore a code base, see what namespaces are available, and see what you have in a code base without having to like flip through a bunch of different source files. And this is also great for your own project documentations to have as public because it saves people so much time when they go to interact with your stuff. Automation. There's a lot of things that you can automate. I could probably do a whole other half panel on just automation here. The main things to highlight are automated release creation, automatic pull request checking. So if someone checks in like a JSON file, you can verify that it's formatted correctly in the way you want it to be. And also automatic website and documentation generation. So the Doxygen stuff I showed you in the last slide, that is all automatically generated every time I push to the repository that it's in. So if I make any code changes, all of that documentation there will be automatically updated. I also do have a badge creation and whatnot. There's a lot here. Pretty much all of my repositories use it though, so if you're curious, that would be the place to look for what you can really get into. Distribution and user experience is also really important. If your software is open source, you really should make it feasible for users to be able to help maintain it, either through comments or, like I said, documentation comments. You should also ensure that proper documentation exists, at minimum for just installing the system into Worlds. You should implement editor tooling as well to streamline installation process. So for example, you can have a system that just places the prefab in the world, and all you have to do, you don't have to dig through folders or anything, it just shows up in your top bar. And you can just directly click a button and it'll add the prefab directly in. The main thing is you just really want to eliminate friction with both the in-client users, which is the normal goal, and you also want to eliminate friction with users using the Unity editor itself, because I've seen this a lot where a system can be really, really good in client, but the editor side experience is utterly horrible and it makes me want to die inside trying to use it. The thing is, you can have the best in-client experience ever, but if your editor side experience is so bad that world creators don't want to use it, or like they have to have a lot of experience to use it, it doesn't matter how good your in-client stuff is, it's not going to be in the world in the first place. So getting the editor side stuff working is extremely important for that. And documentation is part of that. The VCC, it's really just a package manager. There was a lot of concern when the VCC first came out that it was extremely proprietary or whatever. Really all it is a package manager at the end of the day. It allows you to do a bunch of dependency checking and whatnot, and I'll get into that in a second, but it's really not that scary to use. Once you understand that it's just a package manager, it makes a lot more sense. Semantic versioning, there's a lot that I could go into here, but the essential thing is you have major, minor, patch, and then if you're looking at like a release candidate or alpha or beta, you'll have tag and a revision for that as well. If you're curious on more specifics on this, you can go to semver.org. They have a whole very nice to read write-up on how the standard works and whatnot. This is how pretty much every single software project defines their versions. There's some that go a little wacky and don't do this at all. Specifically, VRC doesn't do this because they thought that they wanted the major version to be indicative of what the SDK number was. So it's always going to be 3 while we're on SDK 3. And I do not like that because that's not what that's supposed to mean, and it doesn't follow Semver anymore. But they make some wild decisions sometimes, so that is what it is. But essentially, this allows you to define things for dependency checking to make sure, like, if someone builds something off of your stuff and you change something that's major in the API, they can then make sure that their package isn't going to break when it gets updated. The VPN package standard, there was also some debate about this when it first originally came out. People were saying that it was essentially proprietary. It is not, really. The VPN package standard is essentially the Unity package standard with a few additional keys added on top of it for VCC specific things. This also means that you can just add a VCC package in the Unity package manager if you really wanted to. Not that I recommend doing that. But it is technically an option if you wanted to, and it would work. You'd do some dependency checking things, though, for various different reasons. There's quite a few benefits to developers, though, with the VCC, and I've already kind of touched on these. Simplified release distribution. You go in the VCC, you see all those update markers. That is pretty much all automated for package maintainers. It automatically makes a JSON file that has all of that. In my case, in a lot of my projects, I just need to click a single button, and it'll automatically do all of that for me, and then I just have to update the release notes. It simplifies the speed for doing all of this a lot. Same with distributable hotfixes. You can just push a hotfix, and if people are having issues, they can just go check for an update, and it's directly in the VCC instead of having to navigate to, okay, where was this GitHub project at? I gotta go read the release notes. Like, it's a lot simpler. And yeah, dependency checking. You're able to check on if something else is within a version range that you need, and if not, you can warn the user that, hey, stuff may be broke because this has changed a significant amount to where it might break things. So kind of near the end here, some additional projects to be on the lookout for that I'm working on. The VRC SDK documentation project. It's essentially an attempt to document the entirety of the VRChat SDK, at least as it pertains to worlds right now. We are about, through an estimate of what is exposed to Udon that you can compile, we're about 15% done. There's about 800 things that we have to document, and we're 15% through that. I don't remember what that number is off the top of my head, but this essentially gives you those language server highlights over everything in the VRChat SDK. That's at least the goal once we're finished with it. So you don't ever have to open up the VRChat documentation website, which is formatted differently for almost every page. I have a tools repository. There's a lot of different things in there. Various things from light probe generators to FPS controller to some actual like Udon packages in there. And then I also maintain OpenFlight with my co-creator Matt Shark. He does pretty much all the flight stuff, and then I do pretty much everything else. That's kind of where I've gotten the experience for doing this. Pretty much everything shown in this panel is either direct samples from that project or based off of things that I put in that project. So if you want to check out how any of the stuff that I've shown in here is used, I would recommend going over to that GitHub repository and just looking through and seeing how it's actually used in full there. Tools I've used, Highlight Me. I've used that for highlighting all of the code in this presentation. That's why it's all colored. I use the Fruity style in that. KeyVis 2.0 for the key binding visualization in the videos that I did at the start. And then if anyone's curious what my VS Code theme is, it's Monokai Vibrant. It's one of my more favorite ones that I've tried so far. Here's a direct QR code to this presentation. Again, take a picture of this with your VRChat camera, and you can open it up later if you need. But this will give you access to the Google Slides presentation, so you can go through all of this later if need be. And kind of use it as a reference and get access to more of the links that are kind of longer, or some of the QR codes you might have missed. Lastly here, and I'll transition back to that in a second here, I will be opening a separate instance for Q&A in the associated Discord channel in the Furality server. I'll be putting an invite link in there for more one-on-one Q&A, since I'm already over time as it is. So we don't have time to do it in the official stream, sadly. I will also be responding to questions there during the entirety of the remaining time at the con, including to, I think we go up to Tuesday, I believe. either Monday or Tuesday. I don't remember off the top of my head. But I will be responding up to there as well, and I will also be posting my Discord server link in there. If you want to have a more direct place to kind of talk about this stuff. So yeah, switch back over to QR code here if anyone else still needs to get pictures of that. But yeah, I want to thank everyone for coming out here and just listening to me kind of ramble for a little over an hour, well, under an hour, almost an hour at this point. It's a lot of random stuff, I know. A lot of it might have currently got over your head, even if you know a lot about it. But this is set up, this will be available later as a video to go through as a reference, and of course you have the QR code for going through it. So if you've forgotten anything, you can just go through and look through there for anything. And of course, if you have any questions as well, feel free to ask me. I'll answer pretty much any question about Udon stuff because it's extremely intricate, complicated depending on what you're doing. But yeah. About it.